Today we are going to learn about the changing Earth, and in this chapter we are going to learn about the continental drift theory and also the spreading of seafloor and also endogenic and exogenic forces with a few examples, and I will show you exactly what is going to be happen in volcanoes eruption and all. So what do you mean by changing Earth? So the very first thing we need to learn about the concept of Pangea. What is this Pangea? I will show you a picture. In this picture, you can observe two figures of the Earth. So this is about Pangea and this is about the separate continents. So what is mean by Pangea? Pangea is nothing but a supercontinent. The landmass which is having and the entire landmass together formed into a supercontinent like a solid landmass. If you observe this picture in this, there is no gaps between the landmass. It's formed as a single continent, as a supercontinent. So this is nothing but Pangea. So if you observe this picture, so there is a gap between each and every continent, like it broke down into multiple continents, and the gaps between these continents you can see observe clearly. You can observe clearly here. So there is a seafloor spreading and continental drift theories you can observe. So in the next topics we are going to learn about this continental drift and seafloor spreading concept. So coming to this seafloor spreading and continental drift theories, we are having some information related to this along with the picture. So if you observe here, there is a there is a breakage between the land masses, and it is not like a supercontinent. Like it is not a single supercontinent. It is having some multiple continents along with breakages. So people first believed that continents were in fixed positions, like there is no movement of these continents. However, the distribution of land and water is not always same uh, as it is today. So the thing is, land and water is not equally accessible or not equally distributed all over the earth. So in 1912, Alfred Wegener, a German meteorologist, he proposed the area of Pangea. So previously we learned about what is meant by Pangea, and I showed a picture also related to this Pangea. So yes, Pangea is nothing but a supercontinent. Later this Pangea broke and there was a horizontal displacement of the continent, which I was showed in this picture already. So if you observe this picture, there is horizontal displacements of continents. So this Wegener theory of continental drift is going to happen by the displacements of the land masses. He improved by adding the idea of seafloor spreading also. So if you observe what is meant by seafloor spreading, it is a geologic process in which these tectonic plates, like if you observe here, you are having large slabs of the continents. No, these slabs will split apart. In this, the arrow is showing the split of continents apart from each other. So the seafloor is spreading split apart from each other. And what is meant by continental drift? It deals with the distribution of ocean and the continents. So what is plate tectonics? In this picture, so if you observe first this picture, it is about 240 million years ago, and this is about 180 million years ago, and this is about 85 million years ago, and this is coming to the present scenario. So the what is meant by plate tectonics? The earth crust consists of plates. Just now I explained about the large slabs of the continent, nothing but plates. That is also called as lithospheric or tectonic plates. We are having 6 major and 20 minor plates which are independently floating, that will float independently. The rate of movement of these plates is about a few millimeters each year, extremely slow. So it is not a sudden process, it is not a very fast process, it is very extremely low and slow process which will be a movement of few millimeters each year. The rate of movement is just few millimeters, and we can say it as too slow. Movement by the internal heat of the earth is continuous. So we cannot say it as sudden things. When we are having a continuous process, the internal heat which is generated inside the earth can displace the continents. The movement is caused by the internal heat of the earth only. The surface area of the plates is very large compared to its thickness. So when we compare this thickness, The surface area of the plates is very large compared to that thickness. So the thickness is somewhat thin compared to the surface. Based on the various forces these movements takes place, like we are having two broad categories, endogenic force and exogenic forces. So endogenic is completely within the earth and exogenic force is on the surface of the earth. So coming to this details of endogenic forces, it's a sudden or slow movements or can be both. It causes horizontal and vertical movements also. These movements give rise to varieties of relief features. The sudden movements experienced through volcanic eruptions and earth. So we are having some information related to this earth movements. It's all about geomorphic process. So in this category, we have two broad categories, endogenic and exogenic. Coming to this endogenic, we are having slow movements and sudden movements. Slow movements is nothing but it will takes time to build, like it's a continental building activity or mountain building activity. Continental building activity we can call it as also called as aberogenic, and it is a vertical movement. And mountain building, it will takes place in horizontal displacement only, and we can call it as orogenic also. In this vertical also we can have two types of movements, upward and downward. In this horizontal we can have two types, force of compression, force of tension. So through this compression forces we are having fold mountains, and through this tensional forces we are having fault mountains. Coming to this exogenic force, weathering, erosion and deposition, these are the three broad things we can classify from exogenic things with in this weathering. Physical, chemical, biological things we can classify. So it may be physical, it may be chemical, or it may be biological. So what is this erosion? Running water, it is nothing but the erosion takes place through the river. Groundwater, there is itself is the answer. Groundwater is nothing but which is flowing under the ground or inside the earth, which is percolating under the ground, and it will carry those sediments to somewhere and deposit somewhere. It is keep on flowing means it will keep on eroding something. And glaciers, the while the glaciation is happening, the glaciers will melt and it will carry some things to deposit somewhere. We can call it as erosion. And waves and currents, it's a continuous process in the ocean and seas. If you observe these waves and currents, it's like a circular energy, it will keep on circulate something and it will erode. Winds, it's a basic common type of erosion through our eyes. Wherever we go we can observe some kind of erosion through this wind. So it may be dust particles or it may be something else. So through this winds easy erosion will happen. So what is this deposition? So whatever I explained in erosion, that all the things will carry and deposit somewhere. What they are going to deposit, we are calling it as deposition. So in this we are going to learn about the volcanoes. So in this picture there is a clear internal structure of the volcano. If you observe this, whatever the chamber where the magma is present, we call it as magma chamber. When this magma comes out, we call it as lava. So the thing, if it is inside the earth or inside the chamber, we call it as magma. When it comes out, we call it as lava. So what is the place it is coming out? We can call it as this opening as vent. So when it is coming out, it will release some kind of ash clouds like CO2, SO2, H2O. It will mixed off some gases and we can call it as ash cloud. So this opening, main opening, we can call it as vent, and this side opening we can call it as side vent. So whatever the ash cloud forming, it will fall as ash fall. So this place, this bowl like structure, we can call it as crater. And the lava which is coming out is nothing but from this magma chamber is nothing but lava. So this horizontal place is nothing but sill, and the main stream, it's like a stem of the tree, no, this we can call it as conduct. This is the rock layers of the earth crust. So here I am mentioning some YouTube link related to that volcanoes. If you go through this link, you can have some detailed information on volcanoes, how it is evolved, or like how it is going to erupt in like sudden forces, and how it is forming an ash cloud, etc. You can see in this link. Volcano is nothing but a mountain of fire. Previously, we are calling it as a mountain of fire. I already explained what is meant. Vent. Vent is nothing but a circular opening through which hot molten materials erupt suddenly. Fissure, the opening can be a long crack. So it's not a small thing. It is a long crack which is formed, and that opening can call it as fissure. Volcanic cone. It is formed when the erupted materials accumulate around the vent. It is connected to earth interior by a narrow pipe. So this volcanic cone is nothing but it's a accumulated material around its vent, and it is connected to earth interior by a narrow pipe. It seems like volcanic cone. What is this crater? Crater is nothing but a funnel shape. I already explained you that a crab bowl shape like thing. You can call it as crater, and it is hollow at the top of the. So based on the frequency of eruption also, we can classify the types of volcanoes. And we are having three broad categories of volcanoes: active, dormant, and extinct. What do you mean by active volcanoes? Active volcanoes is nothing but frequently erupted volcanoes. So it's like active every time, frequently erupted, and we can call it as living volcanoes. It will throw out gases, lava, ashes, and rocks. For example, Mount Etna in Italy and Stromboli also. And what is meant by dormant volcanoes? It is it will become quiet after erupting. Like it's like a sleeping volcanoes. It's not that much active, but it will become quiet after the eruption. They do not show any indication of eruption in the near future also. Like it will not show any indication like it is going to be erupt in future. It will like sleeping volcanoes. And one of the example is Vesuvius in Italy. And extinct volcanoes, we can completely say it as dead volcanoes. So there is no possibility of eruption in future also. For example, Kilimanjaro in Africa and Rainier in USA. So what is this active volcano? Active volcano is nothing but living volcanoes. Dormant means sleeping volcanoes, and extinct means dead volcanoes. So there is a distribution of volcanoes in two belts. Like we can classify it as two belts. First belt is a circular belt around the Pacific Ocean. In this circular belt, world's most active volcanoes exist, and we can call it as ring of fire. So if you observe this picture, there is a circular belt around the Pacific Ocean. This call it as ring of fire. What is the second belt? It will find along the Mediterranean Sea, mid-world mountain belt. So this we can call it as mid-world mountain belt. So world distribution of volcanoes, coming to it. So how this distribution takes place all over the world. If you observe this picture, the red color markings which are there on this map, you can see the distribution of volcanoes around the world. So for example, Fujiyama in Japan, it's a volcanic mountain. The Deccan Plateau in India due to fissure eruption. So how this is formed means that is Fujiyama in Japan formed through volcanic activities. So we can call it as a volcanic mountain. The Deccan Plateau in India is formed due to fissure eruption. So the earthquakes, nothing but the shaking of the earth surface. It's like bomb explosions or volcanic eruptions or tectonic plates. Whatever the things, it will shake the earth. So simply we can call it as shaking of the earth surface. What is this focus? The place of origin of the earthquake, we can call it as focus. If you observe this, here the origin of earthquake takes place. Then what is epicenter? Exactly vertically above the surface of this focus, we can call this as epicenter. So the intensity of earthquake is maximum at this epicenter. Vibration spread out of as concentric waves of from the focus. So if you observe this, the waves are moving apart from this focus, like it will move like concentric waves from the focus. This seismograph. And if you see the seismograph, what do you mean by seismograph? Seismograph is nothing but measuring the intensity of an earthquake. It's an instrument, It will be horizontal seismograph or it will be vertical seismograph. So in this picture, if you observe, it will record the intensity of the earthquake, how it is happening. And if you see the top picture, that is the disaster. We can observe after the earthquakes. That is how the earthquakes will destroy the buildings or any resource things. Types of earthquakes: tectonic, volcanic, explosion, or collapse. So these are the reasons for the types of earthquakes. So we are having some kind of waves: P waves, S waves, and surface waves. P waves are nothing but travel through the body of the earth. These we can call it as body waves also. It will arrive first, push and pull. So what they travel through can go through solid rock and liquid magma. So it have capacity to travel in solid and liquid also. S waves means nothing but secondary waves. It's a body waves arrive second. So move material up and down. So can go through rock, cannot go through liquid magma. So secondary waves can travel through only through the solid things, cannot move in liquid magma. So coming to the surface waves, travel on the surface, inflict the most damage. In this, we are having Rayleigh waves and love waves. Love waves is nothing but move ground from side to side. Rayleigh waves means move vertically and horizontally. The intensity of earthquake waves is measured on the Richter scale. The earthquake tremors recorded by an instrument called seismograph. Just now I showed horizontal seismograph and vertical seismograph. The science deals with earthquake. We can call it as seismology. The earthquake scientists are called. So there are some people who will study about this seismology. Like they will do research on the earthquakes. We can call them as seismologists. Richter scale can be 1 to 9. So if you observe this Richter scale, an increase in one point of the Richter scale indicates that the force of an earthquake is 10 times greater than the previous number. So earthquake may cause landslides in hilly areas, cracks in earth crust, bursting of river dams, blocking of rivers, and raising or lowering of seafloors of coastal regions. If you observe this, if it is 3 or 2.5 or less, usually not felt but can be recorded by seismograph. If it is light, 2.5 to 5.4, often felt but only causes minor damage. If it is strong, 5.5 to 6, slight damage to buildings. If it is major, 6.1 to 6.9, may cause major damage in populated areas. If it is 8 or greater than 8, we can see great earthquake that can totally destroy the communities near its epicenter. So world distribution of earthquake belts. Distribution of earthquakes. There is no part of earth is free from earthquakes. In some areas it will occur more frequently. The main earthquake belts on the earth are as under follows. Like circumpacific belt, 65% of total world's earthquakes happen here only. This belt coincides with the Pacific Ring of Fire, which includes coastal margins of North America, South America, and East Asia. If you observe this seismograph, you can see the Pacific belt, Afrasian belt, and Eurasian belt. So the green thing is Pacific belt, this is Afrasian belt, and this is Eurasian belt. Mid-continental belt includes Alpine mountains, the Mediterranean Sea, North and Eastern Africa, and the Himalayas. 25% of seismic events recorded here. Mid-Atlantic ridge includes the Mid-Atlantic ridge and adjoining of islands, records moderate earthquakes and are caused due to moving of lithospheric plates in opposite directions. So these three can be classified as distribution of earthquakes across the world. One is circumpacific belt, and one is mid-continental belt, and one is mid-Atlantic ridge belt. Indian earthquake zones are there, and we are having details on earthquake zones of India. The main earthquake belt in India is confined to Himalayan region and Ganga Brahmaputra Valley. Two-thirds of earthquake prone area is this region only. Bhuj earthquake 2001. On 26 January 2001, approximately like 8:45 a.m., severe earthquake struck the Kutch of Gujarat almost 1 minute. IMD measured the Richter scale of 8.1, that means greater damage. 50,000 people died and more than 5 lakh adversely affected. Seafloor spreading of Indian Ocean at the rate of 5 centimeters per year. Gradual northward movement of the Indian plate. The reactivated faults below the surface in the Kutch region. So if you observe this picture in 2, Zone 3, Zone 4, Zone 5. Zone 2 is least active seismic zone. 3 is moderate seismic zone. 4 is high seismic zone. And 5 is highest seismic zone. And Geological Survey of India published the country's seismic zoning map in 1935. The color-coded map shows 4 distinct seismic zones. Here these are the 4 colors and having details of zone 2 to 5. Thank you.